For those who are missing, my apologies. I won't blame a certain student for forgetting to remind me.
It's all Spanish ball, guys.
It is. We have a set of properties from algebra. They can't even see my hand. I don't know why I'm moving it. Set of properties from algebra that we are going to use in an algebraic proof to say the reason why each of these statements is true. And we have already covered the first four. First one because it's given. Second one, use the distributive property. The third line, we replaced negative 5 times 4 with what it equaled to, so that's why it was called substitution. And then we added the same thing on both sides, the addition property, so now we're caught up. What do you think is the reason they could now write this?
Because I added 20 to 70.
Yeah.
And then cancel out the negative.
Substitution.
So we're replacing a negative 20 plus 20 with a 0, what it's equal to. And the 70 plus 20, we're replacing it with a 90, what it's equal to. So there's our substitution. We're replacing one value with something else that it's equal to.
Substitution could be a big wow.
Then, what allowed them to do this? Division property of equality. They divided both sides by the same thing. Oh, this is going to be easy.
Yes.
And then, they got this.
Substitution.
Substitution. They're replacing negative 5 divided by negative 5 is 1. So there it is. And we stop here because this is what we were trying to prove. That's what we were trying to prove.
This is amazing.
Isn't it amazing? Geometry always is.
No.
In fact, they've written a song. It's called "Isn't It Amazing?" It's about geometry. Oh.
Are you serious?
Wow.
State the property. Okay, let's look up here. State the property that justifies each statement. Now notice, if this is true, so here's their statement, then this is true. Here's their conclusion. What allowed them to go from this original to the conclusion? What?
Transitive? He's thinking, I think. No, it's
Jonathan, what is it?
Addition property of equality.
Where do you get the addition property of equality from? What did they do?
They added X.
They added X to each side. Look at this. These two are identical statements, except they have added an X to each side. Notice that's the only difference from what it was before. So if we added the same thing to each side, that is called the addition property of equality. And here's a good way that you can abbreviate it, just like that. We do a lot of abbreviating in geometry, but we want to abbreviate it in a consistent way. So let's try 1B up here. What allowed them to say if 5 equals y, then y equals 5? There it is. That's the symmetric property.
Oh, you got
Symmetric property of equality. All right. So we're getting pretty good at that. What we just did on that previous example with algebra is called a two-column proof, or a formal proof. We have one column down here on the left where we have all our statements that are made. And then we have another column on the right where we have all the reasons. So they just make this big T here to separate it, the two columns. We make all our statements on the left, all our reasons on the right. It's called a two-column proof. It's the most common type we do. So let's practice another one here. They say if the formula to convert a Fahrenheit temperature to a Celsius temperature is C equals, there's the formula, then the formula to convert a Celsius temperature to a Fahrenheit temperature is F equals, and then they give us a formula. Write a two-column proof to verify this conjecture. So what are we given? We're given that, hey, this is true. And if that's true, they say prove this one is true as well, to go the other direction. So on any proof, we start with the given. So there, I have written it down. Very neatly, I have written it down. What's the reason we can write number 1 down?
They gave it to us.
They gave it to us. Precisely. It was given. Look at that. It was given. So then they, what did they use? Multiplication property of equality. They multiplied both sides by 9/5. There it is. Multiplication property of equality. Then they, substitution, they replaced the 9/5 times 5/9 with 1. Not 0, with 1. Substitution property. Very good. Then they, addition property of equality. Very good. Next, substitution. They replaced, the only thing really to replace is this negative 32 plus 32 with a 0, so all we see is f over there. And then, now, let me ask a question. Is this just like what we're trying to prove? No. What's different? The order it's written is different. I mean, it's the same value, but the order that it's written in is different. So what did they do? Use the symmetric property to just flip it around so that it looks exactly like the original one. There's a proof. Those are algebraic examples of proofs for geometry. Now, let's talk about geometry a little bit. We can use the reflexive, the symmetric, and the transitive property with segments and with angles. So reflexive property, the length from A to B equals the length from A to B. It equals itself, reflexive property. Symmetry, if the length from A to B equals the length from C to B, we can flip it around. The length from C to D equals the length from A to B. You get the idea. Transitive, AB equals CD and CD equals EF, then I can transfer AB must equal EF. AB must equal EF. So it works with segments, it works with angles. So these properties are not just good for algebra, they're good for geometry, which is the class we happen to be in. So let's look at a geometry proof instead of an algebra one. So they say if angle FGJ is congruent, if angle FGJ, so that's the angle right there, is congruent to angle JGK, angle JGK, so that's this angle right over here, those are the two angles, and angle JGK, a change in color, is congruent with angle KGH, so those are these two angles right over here, then x must equal 6. Write a two-column proof to verify this conjecture. So notice how we start. And whenever you do proofs, you have to write this down, the given. You state the given in the original. And the given is, well, the angles that are congruent, and they also gave us in the diagram, the measure of this angle is 6x plus 7. The measure of this angle is 8x minus 5. So all of those things were given. Their statement and in the diagram, they gave us all that stuff. And what they want us to prove is that x equals 6. So we have to figure out what did they give us, write it down. What are they wanting us to prove, write it down. And then we draw our nice outline. So our nice big T here, we're going to draw. And on the left, we write down statements. And on the right, we write down reasons. And what is the very first statement we make? We start with the given information. Now, sometimes we don't write it all, but they happen to write every single bit of it. What's the reason I can write that down? Oh, it's given to us. You guys are geniuses. So let's look at their next statement. Now, there is a slight difference between this statement and this statement. They're using the same angles. Do you see what's different in how they wrote it? One says congruent and the other says the measures equal. The given was that we had two congruent angles. Here they said the measures of those angles equal. How can I say that?
Same thing. Substitution.
If they're congruent, they're going to have equal measure. Any idea what we might call that in geometry? Called a definition of congruent angles. It's what it means to be congruent. the definition of congruent angles. Now you're starting to see some reasons that you are going to need to remember in geometry. If I have something that's congruent, it means their measures are equal. That's the definition of being congruent. So that's what enabled us to do it. And they did it with both of these angle congruent measures, in angle congruencies to measures being equal. So what's the next thing that they did? Then they said, the measure of FGJ is going to equal the measure of angle KGH. Now I want you to look at line 2, and can you figure out what they did to be able to state line 3? Transitive. Can you see the order? Angle FGJ equals the measure of JGK, and JGK, there I am again, same thing, equals KGH. So the first must equal the last. It's called the transitive property. Transitive property of equality. Now what they have just said is FGJ, this angle right here, must equal the measure of KGH, this angle right down here. Now that's probably going to be useful to us to know that those two equal each other. So what do you think they did going from line 3 to line 4?
Substitute.
They substituted. The measure of FGJ is equal to 6x plus 7, right here. Or I guess I should go to our original. Up here, there we go. They just went right there. And I replaced the FGH, whoops, the FGJ with 6x plus 7. Where did I get it? The FGJ.
Why is that up to FGH?
That's wrong, isn't it?
The FGH equals FGJ, isn't it?
That should have said FGJ. See, they messed up. That should say J. They said it correctly there, but they wrote it wrong there. All right. So they just substituted. All they did was substitute it. Now it's going to look like one of those algebra ones because we have an algebra statement. What did they do? Addition property of equality is what they did. What did they do then? Substitution property of equality. Subtraction property of equality. Substitution property. That 6x minus 6x is gone and all I have is 12. Substitution property. Then they did division. They didn't even do that in red and you still figured it out. Division property. And then substituted. 12 divided by 2 I can replace with a 6, etc. Substitution property. Is that what I was trying to prove? Almost, isn't it? So we need to do what? Flip it around by use of the symmetric property, and we have arrived at exactly what we were trying to prove up there. So that's how proofs work. One step at a time. Why don't you write down what's going to be the bookwork, and I'll hand a worksheet to you. Hold on, look here. Oh, wait.
Can I get the concept?
Let's see, we'll have to figure out how we are going to do this. How we're going to do this a little bit, aren't we? We will attempt. You moving up with these together.
The rest can be as normal. Not be distracted by other things. Oh, yeah.